So what I propose to work on is a study of cryptographic protocols with advanced functionalities. So what this means is that, we have sort of these protocols that allow us to achieve basic tasks like being able to talk to each other securely or being able to ensure authenticity of documents, something like that. It turns out that this is not enough to enable sort of the fancier tasks that we want to be able to do down the road, like, if we want electronic voting, or if we want authoritative leaking, if we want anonymous transactions, things like this. We need to construct more interesting exotic protocols. A sort of competing problem in cryptography right now is that we're worried about the rise of quantum computers. Most of the cryptographic protocols that exist right now, or at least the ones that are in wide use, will be broken by quantum computers because they rely on the difficulty of problems like factoring or computing what are known as discrete logarithms. It turns out that classically we don't know how to do this. Like on my laptop, I would never be able to factor these things fast enough, but on a quantum computer, it's quite trivial. What we want are so-called post-quantum protocols. So these are protocols that still run on your computer, on your normal classical laptop, but which somehow resist these attacks from quantum computers. And so I'm working at the intersection of these two things, and this is what I've asked for the funding for. We just had a visitor a few weeks ago, paid for out of this fund, and we were extraordinarily successful in our collaborations. She was here for just maybe 4 days, and we made great strides on constructing code-based blind signatures. We think we've got it almost put together at this point, but also even more exotic protocols. If we can make improvements to these things, it will have ramifications in a lot of modern cryptography. So we're bringing in good people up to Virginia Tech to collaborate and make great strides in research. One of the big things is that in principle, when I'm as a mathematician, like I'm applying for grants all the time, and I'm trying to get lots and lots of money from NSF. But along the way, you need to have preliminary results in order to justify to NSF that they should give you money. And something like the ADS Discovery Fund, which has given me a non-trivial amount of money, something I can use to invite visitors up and get a little bit of that seed research done, is extraordinarily valuable for that reason. Just to get the preliminary results done so that you can apply for more money down the road and grow your research program.